Welcome back, everyone. So today in this video we're going to be talking about refraction. Alright, so what is refraction? Refraction is the bending of light as it passes from one medium to another. So in other words, as light passes from, say, air into water, that light will bend. Okay? Pick any two substances that light can travel through, not something opaque like wood, but glass, water, diamond, corn oil, stuff like that. The light will bend as it passes from one substance to another. Now, how much that light bends is going to be a topic for another video. What we're going to talk about in this video is another consequence of refraction, and that is how much does the speed change within that material. That's right. By refracting light, you're actually changing its speed. Now, the amount that the speed changes is represented by the material's index of refraction. Okay? Now, the index of refraction is a value that is represented by the ratio between the speed of light in a vacuum to the speed of light in a substance. So here we go. Lowercase n is your index of refraction. Your c is the speed of light in a vacuum, that 3 times 10 to the 8 meters per second. And your v is the speed of light in that substance. Okay? Now, let's take a look at this equation and see if we can come up with any properties of the index of refraction just by looking at the equation. Okay, now, the first thing that kind of pops off into my brain is you have a speed divided by a speed. So that's meters per second divided by meters per second. Those units cancel out, which means that the index of refraction is unitless. Index is unitless. Okay? So the index of refraction is unitless. Now, there's one more thing that's quite important that we can kind of determine from this equation, and it all stems from this c right here. All right? Now, remember, the speed of light in a vacuum is the fastest anything can go ever. Right? You cannot get faster than the speed of light in a vacuum, which means anytime light is refracted, it must slow down. Well, if this value, your numerator, is always greater than your denominator, you're going to have a value that's always greater than 1. So what that means is your index of refraction will always be greater than 1. Okay? Now, what does this mean? Well, it means that if your speed is faster, you're going to have a lower index of refraction, right? That means these two numbers are closer. If your speed is slower, you're going to have a larger index of refraction, which means that these two things are a bit further away. All right, so those are some key things to know about the index of refraction. One more thing that's interesting about the index of refraction is that it does have a dependence on the frequency of light that we're talking about. Let's think of a prism for an example. Light from the sun, white light, will come down. You'll get it through your little prism, and on the other end comes a rainbow. Why is that? Well, each color has a different frequency, and each frequency refracts a little bit different. Okay, so the index of refraction for any given material is dependent on the frequency of light. We don't need to focus on that per se. All we're looking at is that equation, understanding that the index of refraction is the speed of light in a vacuum divided by the speed of light in that material. Okay, any question they give you, they'll tell you what the frequency is, and since that's not even in an equation, it's not really a big deal to take into account for right now. Okay, beyond that, we'll be focusing on how much, like the amount that light bends, in another video, where we'll talk about something called Snell's law, and that will take a little bit longer time, so that's why I wanted to kind of break it up into these two different videos. So until next time, I'll see you later.